Concept of a two-sample t-test through an example. So let's begin by supposing we had the following question. We wonder, a lot of us listen to music when we're doing things, and a question might be, if people are listening to quiet classical music, are they better able to concentrate than people listening to popular music with lyrics? So suppose we wanted to test this and see if in fact people listening to quiet classical music were better able to concentrate than people without or listening to popular music with lyrics. And so what we need to do is have two groups of people, one listening to classical music, one listening to popular music with lyrics, and have each of them try to do some things that involve concentration and see how each group does. So we need to begin this test by determining what our null and our alternative hypotheses are. Okay, so what we're going to do, though, is, as we stated, we'll split the people into two groups. We're going to have the people in each group individually attempt to complete 35 tasks that require concentration. And the people in one group will be doing that while they listen to quiet classical music. The people in the other will do it listening to popular music with lyrics. And this will be what we call a two-sample, because we'll have the two groups, the one listening to classical music and the one listening to popular music. And we call it a one-tailed test. The one-tailed refers to the fact that we're looking to see if one group is actually better, will give higher results than the other. If we were looking to see if there was a difference but weren't sure which group would come out ahead, then we'd end up conducting what we call a two-tailed test. And we'll go over that more later. So here are our null and alternative hypotheses for our test. The null hypothesis would be that people who listen to quiet classical music will not be able to complete more tasks than people who listen to popular music with lyrics. And the alternative is that people listening to quiet classical music will be able to complete more tasks than people who are listening to popular music with lyrics. So what we're going to do is we'll have two groups. We have 15 people that are going to attempt the tasks while listening to quiet classical music. And here are the results for those 15 people. Each of these numbers is the number of tasks out of the 35 that they're able to complete. And then we have another group consisting of 13 people that are going to attempt the tasks while listening to popular music with lyrics. And here are their results for doing this. So you can see overall that if you look at the numbers up here versus the numbers down here, it appears that the people who listen to quiet classical music do in fact complete more tasks than this group that are listening to popular music. But what we need to do is actually conduct a test and come up with a p-value to see whether we feel that that really is the case in general. So to conduct our test, we take those numbers that we were just looking at, and we'll need to compute something that's called a test statistic t. And the way we do that is using a formula, and we need to have the mean and the standard deviation and the sample size for each of those two groups. Now I'll go over a little bit. Well, the mean is easy to calculate. The standard deviation we can get off the internet or using our calculators. I've calculated the mean and standard deviation for both of these, and these are the results that we get. For the first group, the one listening to classical music, their average number of tasks completed is 23.13. Here's their standard deviation. Their sample size is 15 people in the group. For the group listening to popular music, their average number of tasks is 20.77. You can see it's lower than this. The question is it enough lower that we think that that would be the case for everybody? Here's their standard deviation, and there's their sample size. So what we do is we take those values, the mean, the standard deviations, and the sample sizes, and we compute something called t, And the formula for t is this. Right? We take the difference in the means, we take the larger of the two means minus the smaller of the two means. We just want the larger minus the smaller so that we get a positive number that we'll be able to use with a table in a little bit. And we divide that by the square root of the first standard deviation squared divided by its sample size plus the second standard deviation squared divided by its sample size. So these numbers down here are subscripts which indicate which group we're in. So this is the mean from the first group, standard deviation from the first group, and sample size from the first, and then the same things from the second. These, of course, are squares, part of the formula, and we need to be careful that we don't forget those or we'll get incorrect results. So we simply take these numbers up here and put those into the formula. So we'll have 23.13 minus 20.77. We divide that by the square root of the first standard deviation squared, so 2.924 squared divided by 15, and then plus our other standard deviation, 3.787 squared, and divided by that sample size, which is 13. And I've computed this. I'll have another video showing how to actually go about doing that on your calculator. But the result in this case is 1.824. And when we find these t's, we're going to round them to 3 places past the decimal because that's what the table we work with will use. So this number, the t, this is our t, and this is roughly the same sort of thing as the z's that we came up with when working with the normal distribution. Now once we have the t, then what we're going to do is use a table to find a p-value, but we need one more thing. We need something that's called the degrees of freedom. And when we're conducting a two-sample t-test, the degrees of freedom, which we abbreviate df, is the smaller of the two sample sizes minus 1 each. So the degrees of freedom is the smaller of n1 minus 1, so that's 15 minus 1, or 14, and n2 minus 1, which is 12. Okay. So we take each of our sample sizes, we subtract 1 from them, and then we pick the smaller of those two numbers. So that means in this case our degrees of freedom is 12. So now that we have the t of 1.824 and the degrees of freedom of 12, we can then figure out what the p-value is. And the way we do that is we use this table, the t-distribution table, and let me jot down those two. Well, I guess there's a little room right here. Remember, our t is 1.824, and our degrees of freedom is 12. So the way we use this table, if you notice, here's a df for degrees of freedom. We go down the left side until we find our degrees of freedom, which is 12 right here. And then what we need to do, these are t values here, and these are the p values up here. These are our p's. So we go across the 12 until we find where our t of 1.824 would fit. And so the 1.824 fits between these two values. So what we do then to figure out the p is we go up to the top and look at these two, and our p-value lies between those two. Now if a number is between two numbers, that means it's less than the bigger number and more than the smaller number, and this guy is smaller. And this is bigger, so that means our p is less than 0.05 and greater than 0.025. Kind of jammed things together there, but that's what we're looking at. And our concern generally is how small the p is, so we always want this inequality here. So we're always going to take our inequality from the left of the two numbers that are above where our t fits. So we go up to these two and we use the left-hand one. We get that our p is less than 0.05. And as we know, that's relatively small. A common alpha would be 0.05 level of significance. So if our p is less than 0.05, we would most likely reject the null hypothesis. So let's go back and take a look. What was the null hypothesis? Well, the null hypothesis is that people listening to quiet classical music will not be able to complete more tasks than people listening to popular music with lyrics. And since we're rejecting that, that means that then we believe the alternative to be true. So our conclusion would be that people listening to quiet classical music will be able to complete more tasks than people who are listening to popular music with lyrics. And our p-value, if we were to state that as a conclusion like that, we'd have a p less than 0.05. So that's how we conduct a two-sample t-test. And if you need some help with finding the t on your calculator, look for the other video on that.